So one of the coolest features in TensorFlow 2.0 is that it's now using Keras as its first-class citizen on defined neural networks. From a TensorFlow perspective, this is pretty cool. From a Keras perspective, this doesn't change too much. The only thing is that it gets a bit more tightly coupled, and that has a special advantage. On the other hand, I was a bit hesitating because I thought Keras and TensorFlow should be separated, but anyway, I was using most of the times Keras together with TensorFlow anyway, so it's not that much of a pain. And in addition, you can all the time export the Keras models to a H5 file and use it wherever you like, for example in Deep Learning 4J or in SystemML, so it doesn't matter, okay? So let's double check whether we are running on TensorFlow 2. So this is the case. So since the MNIST example is very boring, it's the Hello World image classification example which everybody's using. I have here another example, which is the fashion MNIST example, where you, in contrast to classifying handwritten digits, you are classifying clothes, so fashion articles. So let's have a look how this looks like. So as the MNIST dataset, it has 60,000 training examples. Each image has 28 by 28 pixels. And here you see it's basically a single column of labels from 0 to 9. So if you plot this, we get an error. Okay. Mat import matplotlib dot pyplot as plt matplotlib and we need to use some magic. Matplotlib inline. Okay, so this is a shoe basically. Okay, so let's normalize the test and the training data. We just simply divide by 255 because then we get a range between 0 and 1. So, and now we define the Keras model. So it looks similar to out-of-the-box Keras, just imports changed here. So you see here tf.keras and tf.keras.layer. So you have a preceding tf here, and also under activation functions you are pulling them directly from the TensorFlow package. So it's a bit of a difference, but still it's basically Keras. And you compile the model, so this is purely Keras syntax, and you fit. Again, this is purely Keras syntax, also purely Keras output. So nothing much is changing there. But still, if even Google decides to use Keras as their high-level API, this, in my opinion, changes a lot, and is a good new move, because TensorFlow standalone is basically a linear algebra mathematical library, and you shouldn't do neural networks on that level. I highly recommend to use a high-level framework like Keras, where you work on layers and not on matrices. That's key to become successful and fast in that space. So let's wait until this is finished. And you see here we get an accuracy of 87.45%. So now we haven't gained anything besides some more complicated looking imports. But now the thing is, you can now use some TensorFlow code, and that's from the package TF distribution, and that's pretty cool, because without changing the Keras part, you can now define that this model runs on either a single node GPU cluster, a TPU cluster, or multi-node GPU cluster. And here you can select a couple of strategies. So this is the parameter averaging style strategy. If you don't know how that works, just check out this video. So the thing is, you can now define this, and here in the default configuration it doesn't change a lot because it runs on a single kernel, but you can then define a variable and specify on which additional nodes this should be distributed, and that's basically very easy to build something like the Google Brain in just a couple of lines of code. So now we move this one ident to the right, and we run it again. So, and now this code, as it is, can run on one node or on 1,000 nodes. The code doesn't change. The only thing you do is you are running within the scope of the parameter averaging server. And yeah, that's basically it. So let's wait until this is finished. One thing I forgot, this actually is only working because I defined the model outside the scope. So of course, if you want to run in such a setting, you need to run inside the distribution strategy scope. So actually it's like this. But anyway, that's not a huge difference. Yeah, that's basically all. And if you really don't like the TF Keras part, maybe because of the fact that it makes migration more complicated, you can still do the following. You say from TensorFlow.Keras import Sequential, and then you say from TensorFlow.Keras.layers import flatten and dense, and then in theory you should be able to remove those. Let's try. I've not tried it before, so let's see. So the code looks a lot more like Keras, so let's see if it runs. Sorry, it's TensorFlow Keras layers, not layer. Yeah, so you see now, this is now actually how it should run. It's now all executed within the scope of the parameter server distribution strategy. And you see here the code now looks a bit more like out-of-the-box Keras. So the only difference is here that you have the activation functions coming from the TensorFlow package, but in theory you can also import ReLU and softmax at the top, and then you won't notice that much of a difference from pure Keras code. And you have the advantage that you can use this distribution strategy feature of TensorFlow. So I think they are working together quite nicely. So I have to revalidate my opinion and video which I have posted 1 week ago. You can see it here. It's not that bad as I was initially thinking, and I think TensorFlow and Keras are actually making a quite good combination.